Yeah, do more work, Ferg. Don't ask us, but definitely you do more work. All right, so I am recording. Uh, Perform the operation and write in scientific notation. Okay, so let's see. Minus. Go for it. Back to number three. If it's positive, I don't understand. Okay. The exponent is negative. That means I move it. Now, if I need to move something, which is like in the case of number six, I can make the exponent negative. So the exponent being negative, it just changes the position. And so when the exponent's already negative, I just change the position just generally because I don't like to keep it like that. But the instructions say put it in k times x in the n form. So that means all of my variables need to be in the numerator. They need to be like whole numbers. So I can't have my variables in the denominator. That's why Dorian had to stop me because t to the eighth power was in the denominator and it needed to be moved up. That's why we got a negative exponent there. All right, 5 times 10 to the seventh. Okay, so I have 3.84 times 10 to the ninth power minus 5 times 10 to the seventh power. When we add or subtract scientific notation, adding or subtracting scientific notation, my powers need to be the same. Okay? My powers need to be the same. Right now, they're not. So I need to make a change so the powers are the same. Okay? So the change I'm going to make is take away two places from 10 to the ninth and make it 10 to the seventh. Now, when I take places away, I need to move my decimal. So right now, I've got 3.84. 3, because you cursed again. 3.84, right? So as I take two places away from here, I'm going to move the decimal place two places to the right. So I'm going to have 384 times 10 to the seventh power minus 5 times 10 to the seventh power. So now my exponents for my powers of 10 are the same. And so now I can just stack these on or line them up and do my operation. So I got 384 minus 5. So I got 379 and my exponents stay the same. So I'm going to have 379 times 10 to the seventh power. But see, that's not in scientific notation because scientific notation, you can only have one number in front of the decimal place. So I need to move my decimal from here back two places. So it needs to be 3.79. So if I'm in this form and I'm moving my decimal place two places to the left, I add decimal places. So now that is 3.79 times 10 to the ninth power. And that's my answer. That's in scientific notation. So now I've got 2.5 oops, times 10 to the ninth multiplied by 3 times 10 to the 18. So now, when we add or subtract scientific notation, you need to change your decimal places, or excuse me, you need to change your powers to where they're the same. When you multiply or divide scientific notation, you do not have to change. What you can do is go back to what I was saying a little earlier and treat the numbers and the exponents or the powers as two different things. So I got 2.5 and 3. I'm going to multiply those two things together. And then I've got 10 to the ninth times 10 to the 18. I'm going to multiply those together. No, because we're multiplying. When you multiply stuff that's got the same base, what do you do with the exponents? Oh, you said it's 14. I'm sorry, I misunderstood. Yes, you're absolutely right. Dang, only two pieces of candy. Okay. When you add or subtract, the decimal, the powers need to be the same. When you multiply or divide, they don't need to be. You can take them how they are. So that's why I'm not moving any decimal places when I'm multiplying. Thank you again, Dorian. So on the paper, I said on the paper it says 14. I said 9, so I apologize. That's why you never use pen when you're doing math. So anyway, it's 2.5 times 10 to the 14 times 3 times 10 to the 18. So I'm going to take my powers of 10 and I'm going to take my two numbers. Okay. So 2.5 times 3 is 7.5. I just multiplied 2.5 times 3 is 7.5. Now, 10 to the 14th power times 10 to the 18th power. They are two things that I'm multiplying that have exponents and they have the same base. So I just add the exponents. So that's going to be times 10, right? To what? The 32nd? And that's my answer. That's in scientific notation because I got one number in front of the decimal and I got my power of 10. So I don't have to make any adjustments there. Okay. Oop, definitely not what I was trying to do. Yeah, it's catching up to me. I got all these windows open. Oh yeah, I'm saying I couldn't get to it because I had all these open. Yeah, I'm saying it's catching up to me. Yeah, see the most recent one is way over there. Yep. So I had to get rid of some of those. They'll be all right. Okay. Okay. Yep. Just give me a second. I'm gonna create another one and then move back to that one. Okay. Like I said, I'm recording it so you could just watch it and write it down. That way I can get through it more, or I can just wait. Yes, sir. That works. Can I move on now? No problem. Okay. So number 9, I've got 4.38 times 10 to the seventh power divided by 2 times 10 to the 21st power. Now, just like I was telling you earlier, when you have scientific notation that you're multiplying or dividing, you don't have to move your decimal places. You can think of these things as two separate pieces of the same pie. So I got this and I got this. So the first thing I'm going to do is do my division for the first part. I just got to say that again. No, you just need to be able to do the operation. So 4.38, I'm going to divide it by 2. So I don't need to line it up. I just need to divide by 2. So what's that going to be? That's going to be 2 point, let's see, 1. 19. And then, so now I've got what? Somebody else I thought asked a question. 30, 36. So anyway, I've got 10 to the 7th power and 10 to the 21st power. When I divide stuff that has exponents that have the same base, what do I do with the exponents? I subtract them. So I'm going to have times 10, and I'm going to say 7 minus 21. What's 7 minus 21? Negative 14. Because that's 7. Think of the line right here as a subtraction sign. So 7 minus 21 is negative 14. Yes. Because this is in scientific notation, you don't have to do anything else. 4.38 divided by 2 is 2.19. No. So, what is the third root of 64? 4. The third root, nope. The third root of 64. That's 64, and you're taking the cube root. What number do I take to the third power to get 64? 4. What about the fourth root of 16? 2. 2 to the fourth power is 16. Nope. Okay. Rewrite. Let's see. Rewrite the exponential expression as a radical expression. Spelled it wrong. Radical expression. Okay, so what are we talking about? Well, if we look at 12, 8 to the 1/5 power, that is a fractional exponent. I need to write it as a radical. So what is that? The fifth root of 8 to the 1 power. In mathematics, we don't put that 1. So that's all I do. 10 to the 3/7 power. 10 to the 3/7 power. If I want to write that as a radical expression, I'm going to have a radical that's going to have 7 as my root, and I'm going to have 10 to the third power. You need to know what 10 to the third power is. It's 1,000. Every your exponent just tells you how many zeros you got. So if you got something under there, you need to be able to multiply that. So that's 13. Yes, you would lose half a point. I totally agree that you should be able to multiply. You're right, that's crazy. So anyway, now I've got 2/3 taken to the 2/5 power. Doesn't matter that it's a fraction, I do the exact same thing. What's my root? That's going to be fifth root, and then I got 2/3 taken to the second power. Nope, it's going to be 4 to the right. It's going to be 4 to the ninth. I'm expecting you to do this. That 2/3 to the second power is 4/9. So you can do that. 2 to the second power and 3 to the second power. All right, 15. I've got 11 to the negative 1/2 power. So anyway, what is that? Well, it says 11 to the negative 1/2, so I know that it's going in the denominator, and that's radical 11, or the square root of 11. Now, we're going to cheat because I'm going to let you get away with this. That, and there's other things you probably should do. We're going to call it right there. So We're gonna call it. Yes, because the exponent is a fractional exponent. It's one half, but it's negative one half. So negative says change position. Look at what happened with the 12th one. 8 to the 1/5 power is the fifth root of 8. So 11 to the 1/2 power would be the square root of 11. But to the negative one half, it kicks it to the denominator. So the negative changes position. You can't have a radical in your denominator, but for this test, I'm not gonna say anything. You put the radical in denominator, we calling it. All right. Nope. 16. I got p to the 5/8 power times p to the 1/4 power. The rule is that when you've got things that you're multiplying that have exponents, right? And they have the same base, you add the exponents. So in this case, you're going to have to add fractions. I got 5/8 and 1/4. I need to add those fractions. What do you do when you're adding fractions? I need a common denominator. So I'm going to change that. That's 5/8. I'm going to change 1/4 to 2/8. That's going to be 7/8. So my answer is p to the 7/8 power. I multiply the top and the bottom by 2 so I can get a common denominator, which is 8. And then I can combine them once they have a common denominator. 17, 2x to the 1/5 power taken to the negative half power. So I told you I got numbers and I got variables. So I'm going to treat them as two things that are different. So I got 2 taken to the negative 2 power. What should that be? It's 1/4. Negative tells me I kick it to the denominator. 2 to the second power is 4. So that's 1/4. And now I got x to the 1/5 power. Well, it's to the negative 2. So what am I going to get? I'm going to get x. When I've got an exponent that's being taken to a power, I multiply. So I've got 1/5 times the negative 2. That's just going to be negative 2/5. And we don't put it in the denominator because the problem says change it to k x in n form. So I don't kick it to the denominator. I leave the exponent negative. And that's my answer. It says 1/4 times x to the negative 2/5 power because I took 1/5 and multiplied it by negative 2. On your review, we're going to skip 18. Not going to be on there. So we do got 19 though. So 19, find a sequence of 5 intervals that I'm writing it out for y'all. If y'all don't want me to write it, I'll stop. Contains 2 to the radical 5 power. Okay. Okay. Yep, because it's really difficult. You told me to stop writing. I was writing it. Okay. So the square root of 5 is approximately 2.23606,797. So I give it to you. It comes from the calculator. Yeah, but you still needed it. That's why I was writing it, because it was irrelevant. So this right here. So I took the first place, 2. So I said 2 to the second power and 2 to the third. Then I went to the second place, 2 to the 2.2 and 2 to the 2.3. And then I went to the third place, 2.36, 2.37. And now I'm going to the fourth place. That's 2.360 and 2 to the 2.361. So that's 4. I need one more. So that's 2 to the 2.3606 and 2 to the 2.3607. Got one more problem. Nope. So find the average rate of change for the area of a square. The area of a square is just x squared over the interval of 8 to 9. Well, the formula is f of b minus f of a divided by b minus a. Well, a is 8 and b is 9. My function or my formula, whatever, is x squared. So I'm going to say 9 squared minus 8 squared over 9 minus 8. 9 squared is 81. So I got 81 minus a squared is 64. And that's over 1. So the 1 falls off and I just subtract 81 minus 64. What's that? 1, what's that? 17? And that's my answer. And now that's everything. You're welcome. It'll be in 2 parts.